Gold remains one of the planet's most coveted precious metals. It gleams not only because of its deeply warm hue, but also because of the symbolic promise of wealth, financial stability, and prestige that has accompanied humanity since the earliest records of trade. Today, just as centuries ago, this yellow metal still captures the collective imagination. Yet reaching it requires a complex journey that blends geology, large-scale engineering, precision chemistry, and security logistics worthy of a spy film. Imagine, to begin with, an even older scene. About 4.6 billion years ago, when Earth had only just condensed from stardust and its surface, still plastic, dotted with magma oceans, was bombarded incessantly by meteorites and asteroids rich in nickel, iron, and the entire family of siderophile metals. During that phase, known as the Late Heavy Bombardment, impacts, some as large as continents, embedded massive doses of metallic cores into the cooling crust while dissolving other components into the semi-liquid mantle. Gold traveled in that mix, first trapped in sulfur phases and later redistributed by the gigantic convective flows that churned the interior of the young planet. Over millions of years, tectonic dynamics buried part of that metal beneath thick rock layers, and ascending hydrothermal fluids concentrated it into ultra-fine veins that crystallized in quartz, pyrite, and other silicate fissures. The result is the gold we seek today. Mostly microscopic inclusions, invisible without an electron microscope, tightly embedded in a crystalline matrix that only subsequent geological processes, erosion, folding, or volcanic activity have brought close enough to the surface for modern mining to detect and extract. After countless eras of cooling and volcanic activity, some of that gold was pushed into rock fractures where it crystallized into threads and small clusters. Much later, during the California gold rush in the 19th century, prospectors plunged into rivers and streams after nuggets swept along by flowing waters. Yet beneath their feet lay deposits of unimagined magnitude, merely the surface of an underground metallic ocean. Today, deposit exploitation relies on advanced prospecting technologies. Flying over terrain with electromagnetic systems, essentially giant metal detectors mounted on aircraft, makes it possible to map variations in subsurface conductivity and magnetization. Such anomalies linked to iron-rich sands are good indicators of potential gold. The procedure is costly, but it shrinks the search area dramatically, offsetting the financial risk of drilling blind. To give a sense of the difficulty, of every 1,000 exploration campaigns, fewer than one results in a profitable mine. Once the geological target is outlined, drills capable of boring down 2 kilometers swing into action. In northeastern Nevada lies the second largest gold mine in the United States. Its operator, part of the world's biggest gold multinational, runs a hybrid system. An open pit hundreds of meters across and an intricate underground network like an 80-kilometer ant nest beneath the earth. Surface extraction begins with placing ammonium nitrate and diesel fuel explosives, ANFO, into blast holes precisely distributed according to a shot plan. Each detonation can use between 700 and 900 tons of nitrate, releasing roughly 600,000 tons of fragmented rock. Put in perspective, each ton of ore typically contains only 3 grams of gold. In other words, an extraordinary volume of material must be crushed to fill a single ingot mold. The visible star of the operation is a hydraulic shovel whose bucket is the largest on Earth. Costing more than $20 million, this steel beast needs only 3 scoops to load the bed of a 270-ton haul truck. The full cycle, arrival, loading, departure, takes barely 1 minute, reflecting the almost choreographed efficiency of modern logistics. At the processing plant, enormous jaw crushers reduce rock blocks to gravel size, rotating drums packed with steel spheres, mill balls the size of a melon, then pulverize the ore into a very fine powder. Water is added to form a slurry that flows into tanks where sodium cyanide is introduced in precise millimolar concentrations. Though toxic, cyanide is one of the few reagents able to dissolve gold without excessively attacking other metals. Granular activated carbon is added. Its porous surfaces capture gold ions as though through an invisible filter. Recovering the adsorbed gold requires an electrochemical step. By applying current, metallic ions leave the carbon and plate onto stainless steel cathodes, forming shiny sheets that are periodically scraped off. Yet not all wealth is collected above ground. In the same mine, zones so deep or convoluted require underground mining. Workers descend half a kilometer below the surface, where temperatures can hover around 60 degrees Celsius. In that sweltering environment, a colossal air conditioning system pushes cold air through galleries reinforced with bolts and wire mesh. Underground blasts repeat the surface sequence, drilling, charging, detonating, mucking, and loading fragmented ore into articulated dumpers that return to the surface. Everything then merges with open pit material and continues through processing. Some fractions contain sulfides that cloak gold particles like armor. To break that shell, the mineral slurry enters pressurized autoclaves, where water and oxygen reach 224 degrees Celsius. The reaction oxidizes sulfides and liberates the metal, ready for another round of cyanidation and electrolysis. During smelting, cathodic sheets are melted above 1,100 degrees Celsius in tilting refractory-lined furnaces. Once liquefied, the metal combines with borax and carbonate fluxes to draw off impurities, is degassed with argon, and, after a quick assay confirming purities near 90%, is poured into preheated graphite molds. In seconds, the golden stream solidifies into brick-sized bars weighing 25 kilograms each worth more than $1 million. Producing a single bar requires crushing and processing roughly 8,200 tons of rock, so the Nevada mine, with its open pit and underground blend, moves colossal volumes of ore to produce about 26 tons of gold annually, more than $1 billion worth. Even then, the gold's journey is not over. Bars travel to refineries where they undergo chlorination, Miller, or electro-refining treatments to reach 99.99% purity. The finishing touch is stamping each bar with a serial number and exact fineness, certifying authenticity for central banks and global markets. Since historical records began, humanity has extracted a little more than 190,000 tons of gold. A significant share now rests in high-security vaults. None is more famous than the Federal Reserve Bank of New York's. Completed in the early 1920s beneath Manhattan, this subterranean fortress holds almost 1/4 of the world's monetary gold. After the Second World War, several governments parked their reserves there for safekeeping during Europe's Reconstruction, and the deposits peaked in 1973, shortly after the United States suspended dollar convertibility into gold for foreign countries. The complex remains the largest custody chamber on the planet. Bars arrive in armored trucks escorted by heavily armed guards, are unloaded with retractable boom cranes, and counted one by one before entering compartments assigned to each nation or financial institution. The mere sight of gleaming stacks, worth hundreds of billions of dollars, is overwhelming. Trying to load that mass into an ordinary car would crush its suspension and tires instantly. Why, after millennia, does gold still fascinate us? Part of the answer lies in its physical-chemical properties. It is malleable, does not oxidize, is relatively scarce, and its unmistakable color makes it stand out from other metals. Yet, there is also a cultural and psychological component. For centuries, kingdoms minted coins backed by gold reserves. Later, central banks reinforced trust in their banknotes by anchoring them to bars. The value we assign to gold is ultimately a collective agreement founded on history and the perception of future stability. As extraction grows costlier and ore grades decline, mining companies invest in innovation, autonomous drilling systems, driverless trucks guided by GPS, and cyanide alternatives that are less harmful to the environment. Recycling jewelry and electronic components is also on the rise, a form of urban mining that recovers the metal from disused devices. Still, as long as global demand remains strong, whether in electronics, jewelry, or as a reserve asset, large-scale mines will continue to star in this saga of rock, fire, and extreme security. This luminous journey begins almost imperceptibly. Minute particles nestled inside millimetric fractures, hidden beneath millions of tons of rock that have endured eons of pressure, heat, and metamorphism. From there, the task becomes a multidisciplinary enterprise combining high-resolution geology, geochemical modeling, and aerial mapping to locate deposits where gold content barely exceeds a few parts per million. Once an anomaly is pinpointed, colossal machinery, hydraulic shovels as tall as buildings, and trucks carrying the weight of a Boeing 747 takes over, removing, hauling, and fragmenting rock with watchmaker precision. Crushing and grinding then reduce the ore to fine powder. Controlled doses of reagents such as cyanide or thiosulfate solubilize the metal, and adsorption techniques using activated carbon or synthetic resins recover it in concentrated form. Electrolysis follows, separating gold via cathodic deposition, and chemical or electrolytic refining lifts purity above 99.99%. In parallel, ventilation engineers keep underground galleries at breathable temperatures. Environmental specialists manage effluents and tailings dams with real-time monitoring, and data analysts optimize haulage routes through artificial intelligence algorithms. Finally, at the smelter, liquid metal becomes standard bars weighed with hundredth of a gram tolerances, engraved with serial numbers and QR codes for traceability, and secured by protocols that include armored convoys, encrypted communications, and vaults monitored day and night. Thus, the entire chain, from microscopic veins deep underground to gleaming bars safeguarded by state-of-the-art electronic systems, highlights a choreography where science, precision engineering, huge capital investment, and humanity's persistent drive to turn risk and effort into a tangible symbol of enduring prosperity converge.